Now let's discuss about our main hormone, that is insulin. So as we had already discussed, what is the source of insulin? It is the beta cells of islets of Langerhans. And what is the action of insulin? The primary action of insulin, it is to lower the blood glucose level in the blood. It reduces the levels of blood glucose. Now about the synthesis of this hormone, it is not directly synthesized as insulin, rather pre-proinsulin that consists of around 108 amino acids, it is converted to proinsulin consisting of around 86 amino acids to ultimately yield insulin consisting of 51 amino acids plus C-peptide. Now what is the C-peptide? C-peptide, it is an index of endogenous insulin production. Because from where does the C-peptide comes? It comes from pre-proinsulin, which is converted to proinsulin, and this proinsulin, it yields insulin as well as C-peptide. So measuring the levels of C-peptide, it can give us an idea about the production of insulin. Okay. Now once this insulin, it is synthesized, it has to be regulated as well. So we shall first discuss about the metabolic regulation of insulin. The primary regulatory factor for the secretion or metabolism of glucose, carbohydrates is glucose. So mainly the secretion of insulin, it is affected by glucose. Now how? By the mechanism of feedback inhibition. Feedback inhibition means when something is increased, some regulatory mechanisms that exist inside the body, they act upon to decrease the secretion of same product. Here in this case, the product is increase in glucose. Whenever the blood glucose rises, there is secretion of insulin. And what is the action of insulin? To drop down the levels of blood glucose. So that will decrease the level of glucose. Now this decreased glucose, it will cause inhibition of insulin secretion. That is how blood glucose itself controls the regulation of insulin hormone. So that is our feedback inhibition, and the main regulator of metabolic regulation of insulin secretion, it is our blood glucose. Now this is a graph that represents the pattern of insulin release with variation in the levels of plasma glucose. Whenever the plasma glucose level, it is below 50 to 60 milligram per deciliter, there is no release of insulin. Why there is no release? Because we had just discussed that the main factor for the secretion of insulin, it is your blood glucose. When the blood glucose is lesser, there won't be any release of insulin. Now when the glucose level, it reaches around 110 milligram per deciliter, as you can see from this graph also, there is a steep rise in the secretion of insulin. There is a sharp rise. But once it reaches around 300 milligram per deciliter, you can see a plateau phase. That means with further rise in the plasma glucose level, there is no increase in the release of insulin. A phase of saturation has been achieved and there is no further secretion of insulin. Now there is a term which is called as the biphasic pattern of insulin secretion. So biphasic means, bi means two. Secretion of insulin in two phases. Okay. So how it occurs? How the secretion of insulin occurs in two phases? So initially, after the glycemic stimulation, there is one peak of insulin release. Once this peak has been attained, within a minute, there is a steady phase. So what do you understand by the peak phase and what do you mean by the steady phase? Peak phase means there is release of preformed insulin. Once this preformed insulin has been released sufficiently, there is a release of regular insulin. That's why following glycemic stimulation, biphasic pattern of insulin release has been observed. First is the peak secretion followed by the steady release of insulin. Okay. Now next factor that affects the secretion of insulin is neural regulation. So first was the metabolic one that we had discussed, in which glucose was the primary factor that was affecting the release of insulin. Secondly, here comes the neural regulation. So in neural regulation, first factor is vagal or the parasympathetic stimulation. It's going to stimulate the secretion of insulin. Paradoxically, sympathetic supply, it will inhibit the secretion of insulin. Now this is a brief representation of other factors that are involved in the regulation of insulin secretion. Here on this side you can see the factors that are promoting the secretion of insulin, the green colored ones. Beta adrenergic stimulation, oral hypoglycemic drugs, glucagon growth hormone, cortisol, prolactin, estrogen, the intestinal hormones, increase in the level of blood glucose. These factors are going to stimulate the secretion of insulin. Whereas on the other side, somatostatin, leptin, conditions of fasting and alpha adrenergic stimulation, it decreases the level of insulin secretion. These are the positive factors, and here are the factors that negatively influence the secretion of insulin.